Russia, the largest country on Earth, and also one of the most controversial countries on Earth. But this isn't about any of that nonsense. Today, what if Russia was a planet? Yo, what's up, home dogs? I'm Luke from BurningZ Media, and welcome to the first video in this series. What if? What if Russia was a planet? So first up, we're going to have to separate it into a few different things. Before we start, it is important to say that this planet would be similar to Pluto in many ways, including the fact that it isn't actually a planet, rather a dwarf planet instead. First up is what would actually happen when Russia became a planet. I mean, there is literally no way this could reasonably happen, so we can't really say how it would happen, but we can delve into what the results would be if it happened. To do this, we are firstly going to have to work out the basic things like the gravity and other nonsense. To do this, we're going to have to do some calculations. For simplicity, we will assume this new Russian planet has the same total surface area as Russia itself, and will have the same overall density as Earth. Using the Earth's volume and mass, we can work out that the Earth's density is roughly 5.51 times 10 to the power of 12 kilograms per kilometre cubed, which converted into a more regular unit of density becomes 5.51 grams per centimetre cubed. This is 5.35 times the density of milk, if you wanted to know. Now we need to work out the volume of this new Russian planet. To do this, we need Russia's total surface area. According to Google, its area is 17.1 million kilometers squared, which is roughly 2.1 quadrillion times the size of a single new British £5 note. The plastic kind. Using some more quick maths, we now need to work out the volume of this new Russian globe. Using a fun equation, we can work out that the volume of the new planet is roughly 6.65 times 10 to the power of 9 kilometers cubed. Now we have all we need to work out the mass of the new planet. Seeing as density is mass over volume, we can rearrange the equation to create the equation mass equals density times volume. So now all we have to do is plug in the numbers, except not yet because we have to convert the units so they're the same and we don't get a painful and wrong answer that makes us think, what on earth have we done wrong? This means that it's easier to use kilograms per kilometre cubed rather than grams per centimetre cubed, as we already have the value for it. So in goes 5.51 times 10 to the power of 12 kilograms per kilometre cubed times 6.65 times 10 to the power of 9 kilometres squared, and out comes the disgustingly large value, 65.6415 sextillion kilograms. We can simplify this a bit by turning it into 65.6415 quintillion tons, metric of course. And we're done. Yeah, no, we've done about half the job, so hooray for fun. Now we have to work out the gravitational force of this new planet. To do this, we're going to have to use Newton's gravity formula, which for all you uneducated scrudders is m1g equals gm1 m2 over r squared, where m1 and m2 are the masses of two different objects. R is the distance apart, which in this circumstance is simply the radius of the Russia globe, and G is the gravitational constant, which is this. So we do still need the radius, which you can work out from the volume using yet another painful equation. Radius cubed equals volume over 4/3 pi. The radius comes out as roughly 1,166.6 kilometers. Plugging in the numbers, excluding m1, we get m1g equals 6.67408 times 10 to the minus 11 times m1 times 6.56415 times 10 to the power of 22 over 1,166,660 squared, with the radius converted to meters. So, what would life be like on this new Russian planet? Would there be human life similar, or identical to us? The answer is no. The gravity on this planet wouldn't be strong enough to hold a reasonable atmosphere, making it highly unlikely for life to be sustained, especially intelligent life, as it lacks breathable gases such as oxygen. And if we finish off this equation and work it all out, we get a fairly reasonable value of 3.22 meters per second squared. So, after all that, what would life be like on this new Russian planet? Will there be human life? Life similar to us or identical to us? The answer is no. The gravity on this planet wouldn't be strong enough to hold an atmosphere, making it highly unlikely for life to be sustained, especially intelligent life, as it lacks breathable gases such as oxygen. The lack of a reasonable atmosphere would also make the planet powerless to harmful radiation given off by the sun. And although depending on the Russian sphere's location in our solar system, there is a chance that life could exist under the layers of water ice, maybe deep under one of the Russian rivers and lakes such as Lake Seliger, most likely animals similar to goldfish due to planet's weak gravity. I thought it might be fun to imagine what if a country became a planet, and think of many different science fiction scenarios. In reality, these hypothetical planets aren't so different from ones we already know. For example, its gravitational strength is roughly a third of Earth's and is comparable to Mars's gravity of 3.75 meters per second squared. And as mentioned before, it's almost exactly the same size as Pluto. So, in the end, we didn't really achieve anything or find anything surprising, but I hope you enjoyed it regardless, and I'll see you in the next one.